All right, so we're going to look at solving equations part 2, and we're going to continue with fraction style. Uh, so what that means is we're going to be solving equations dealing with fractions. So again, as always, our goal when we are solving equations, our goal is to get the variable by itself on one side of the equal sign. So again, our goal, same goal it's been with solving equations. We want to get the variable by itself. And now normally what we've been doing is to solve our equations, we've been doing the inverse operations. And that's what we're really going to be doing here. But how we're actually going to be solving these types of equations is we are going to be solving, so solve, we are going to solve by multiplying by the reciprocal. So if you remember what a reciprocal is, here's that word that comes back up again, reciprocal. Remember, reciprocal is the flipped fraction. So you might want to put underneath reciprocal, flip fraction. And the reason we're going to multiply by the reciprocal is if you remember with dividing fractions, dividing is multiplying by the reciprocal. So that's why when we solve these equations, we're going to multiply by the reciprocal because we're really dividing by the fraction, but in order to divide by fractions, we have to multiply by the reciprocal. So that's how we're going to solve these equations. And then as always, we know we're done. So you're done when the variable is by itself. All right. So again, that's how we know we're done, when the variable is by itself. So let's look at a couple examples. We're going to do 3 examples here. And I'm going to zoom in a little bit so that you can see. So we're going to look at example 1. So example 1. Example 1 is 2/3 x, so 2/3 times the value x equals 4/5. So we have a bunch of fractions going on here. If you remember, a number next to a variable means multiplication. So we have 2/3 times the value x equals 4/5. Let's see here. That makes that worse. That's bad. All right. So, and I talked about solve by multiplying by the reciprocal. Normally, when we undo multiplication, we divide. So we're really going to divide. We're going to divide by 2/3, but dividing is multiplying by the reciprocal. So how to get x by itself, we're going to multiply by the reciprocal. So the reciprocal of 2/3 is 3/2. And if I multiply the left side by 3/2, I have to multiply the right side by 3/2. If you remember with cross canceling, the 3's will cancel each other out, the 2's will cancel each other out, basically just leaving us with this x equals, now we have 4/5 times 3/2. And we can multiply straight across, or if we recognize here, we can cross cancel here. 2 goes into 2 one time, 4 goes into 2 two times. So now we have 2 times 3, which is 6, and 5 times 1, which is 5. So then the value of x is 6/5. Okay. Now again here, we can check. We can plug 6/5 in for 2/3. So if we do, or in for x, we have 2/3 times 6/5. Boom. Multiply, you get 12/15. 12/15, they're both divisible by 3. And you get 4/5, which that's what that's supposed to equal. So this is how you can check, and this is to prove that this works here. So when we see a fraction times a variable, we just multiply by the reciprocal. Let's do another example. Example 2. Example 2, we have 1/7 y, so 1/7 times the value y, equals 4. So we have a fraction, but we also have a whole number. So because we are trying to get the variable by itself, we have to deal with this fraction. We need to move 1/7 to the other side. So to do this, we need to multiply by the reciprocal. The reciprocal of 1/7 is 7 over 1. The 7's will cancel out, the 1's will cancel out, leaving us with y. If I multiply by 7 over 1 on this side, I have to multiply by 7 over 1 on this side. And if you remember, all whole numbers are over 1. So we have 4 times 7, which is 28. And we have 1 times 1, which is 1. And any value over 1 is a whole number. So our final answer is y equals 28. You could plug 28 back in for y. 1/7 times 28 would give you 28 over 7. And 28 over 7 is 4. So that's how we prove that answer. And let's look at one more example. Example 3. Right there. So example 3 is going to be 2 1/4 times the value a equals 16 thirds, or 16 over 3. So here we see we have a value times a variable equals a fraction. So we need to get this variable by itself. Well, we know where they're fractions, so we got to multiply by the reciprocal. But if you remember, before we can multiply or divide, we have to convert mixed numbers to improper. So same thing here. Before I can solve this equation, I have to convert this to an improper fraction. 2 times 4 is 8, plus 1 is 9. So we have 9/4 times the value a equals, we don't need to convert this, it's already an improper fraction, 16 thirds. Now, I can work with this. Multiply by the reciprocal. Multiply by 4/9 on this side. I got to multiply by 4/9 on this side. The 4's go away, the 9's go away, leaving me with a equals. We look, we can't cross cancel the 4 and the 3. We can't cross cancel the 16 and the 9. So unfortunately, we just got to multiply these across. 16 times 4 is 64. And 3 times 9 is 27. So then we get the value a equals 64/27. And that cannot be simplified. So you just get a really funky fraction for this one. All right. So when we solve equations, part 2, so when we see a fraction times a variable and we need to undo that multiplication with a fraction, we multiply by the reciprocal. And you got to remember, a reciprocal is a flipped fraction. So there's that word reciprocal coming up. It's definitely a word you're going to want to know.